In this video, we're going to review the most important theorem to come out of geometry, and that is the Pythagorean theorem. So let's go ahead and look at the Pythagorean theorem. Alright, so in essence, at the right triangle, this is A, this is B, this is C. Alright, so now when you have a right triangle, the sides of that triangle do have names. The side opposite the right angle, this is called the hypotenuse. And then the two sides next to the right angle are the legs. So this is a leg, and this is a leg. And the Pythagorean theorem simply states that a squared plus b squared equals c squared. And so that when you have a right triangle, there's a relationship between the three sides of that right triangle, and it is that the sum of the squares of the legs equals the square of the hypotenuse. Okay, so let's go ahead and prove the Pythagorean theorem. This is probably something you did back in geometry. Prove the Pythagorean theorem. And there's a number of proofs out there. I think once I looked online and I saw there were at least 370 of them. So there's a good number of them out there. But in this particular case, we're only just going to go over one at this moment. And so in this particular proof, and this is going to be an algebraic proof. So back in geometry, you probably did two-column proofs and flow proofs and all kinds of different proofs. And this is going to be an algebraic proof of the Pythagorean theorem. And so we're going to start with four congruent triangles. Okay, so this is going to be A, B, C, and then we're going to have four of these. A, B, C. And of course, congruent triangles are triangles where all the sides and all the angles are congruent. A, B, C. So even though I'm not drawing these exactly the same, we'll just say they are congruent. Alright, so now we're going to take these four congruent triangles and we're going to rearrange them to form a square. So let's do that. Alright, so this is how we do this. Let's see. Let me try to draw this somewhat well. Okay, that's not too bad, so let's see. It's not too shabby. So here we got that, 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 that. So this is one of our triangles, so if you imagine taking this triangle and pull up it right there, that would be A, B, C. And then if we were to take this triangle and just twist it right into there, that would be A, B, C. And then you take this one and twist it all the way around, that would be A, B, C. And then the final one would be A, B, C. There we go. All right, so we create this square because, of course, you have the 4 right angles and you have the 4 congruent sides, so it is a square. Now, of course, the next question is, what's the shape, inside? So we have this side here with all the C's, that shape. And, I didn't draw it very well. So, what is shape inscribed in the square? Okay. Now we know, because all the sides are congruent, that it's at least a rhombus. Okay. But the question is it another square? So let me do a little, let's just take this part right here and let me blow that up. I'm going to create a larger version of that. So this would be A, B, C, A, B, C, and that is a right angle, and that is a right angle. Let me go over here. So let's say this is angle 1 and angle 2. So that means this is angle 1 and this is angle 2, and I'm going to call this angle 3. All right, now we know that the measure of angle 1 plus the measure of angle 2 plus 1, 2, and 90 degrees has to be 180 degrees. Okay, so we know that. We also know that, well, here, let's do this. Let's subtract 90 degrees. So that means the measure of angle 1 plus the measure of angle 2 is 90 degrees. That makes sense. The acute angles in a right triangle are complementary. So we have that. And then we also know, all right, so this is a linear pair right here. So we know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to add up to 180 degrees. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to be 180 degrees. So if the measure of angle 1 plus the measure of angle 2 is 90 degrees, that means we have 90 degrees plus the measure of angle 3 is 180 degrees. So the measure of angle 3 is 90 degrees. So if that angle here is 90 degrees, well, that means all of these are 90. And so that inside triangle, or that inscribed figure, is a square. So all right, so we got that going for us. Okay, so the next thing we're going to do is we're going to look at some areas and compare areas. So first, let's find the area of what we'll call the whole figure, or the outside square. So what is the area of the whole figure, or outside square? All right, so if you look at this figure here, area in general is length times width. So in this case, the width and the length are both a plus b. So we have a plus b times a plus b. Okay, so then what is the area of this inside square? Well, in this case, the area of the inside square, so area is length times width, which is c times c, or c squared. And then, what is the area of one triangle? Well, a triangle is 1/2 base times the height. So if I were to look at just one of these, the base is B, the height is A. So we would have 1/2, base is B, the height is A. Or we could rewrite this to be 1/2 AB. Okay, so here is how this will work. We're going to make the following observation. We're going to notice that the area of the outside square equals, so we have the area of this whole thing right here. It equals the area of the small square plus the area of 4 triangles. So what is the area of small square plus 4 of the areas of triangles? Does that make sense? The area of the whole thing has to equal the area of the square plus 4 of these triangles. Okay, so I need to go to another sheet of paper here. Alright, so the area of the outside square was A plus B times A plus B. Okay, the area of the small square was C squared. And then we're going to add on 4 times the areas of the triangle. 1/2 AB. Okay, so let's go ahead and simplify this. Okay, A plus B times A plus B, we got to distribute that. So that's going to be A squared plus 2AB plus B squared. And here we're going to have C squared equals, well, 4 times, well, not equals, plus, sorry. 4 times 2 is 2, or 4 times 1/2 is 2AB. Well, something nice happens here. The 2ABs cancel out, so let's subtract those. And so then we end up with A squared plus B squared equals C squared. And there you go. There's our Pythagorean theorem. Okay, so this is a pretty common proof that we do for the Pythagorean theorem. Like I said, there's over 370 other types, so you can look those up and find all kinds of different proofs. But anyways, this one uses areas, and it's an algebraic proof, and we compare the areas to come up with this idea that in this particular situation, A squared plus B squared equals C squared.